Welcome to Astronomy, Chapter 15. This chapter marks the first chapter in our fourth and final unit we'll be looking at in this course. Now, this final unit we're going to be looking at is called Understanding the Universe, which, in my opinion, is a bit of a tall task to do. But this section is going to try to be taking the idea of looking at the big stuff, the biggest structures, the biggest parts of our universe, and trying to understand what's going on with them. And because this is the farthest out part of astronomy, and this is the area that we know the least about, obviously this unit we're going to be looking at really on the surface level of how we understand the big parts of our universe. Now, the first chapter we're going to be looking at is taking a look at this thing we call the Milky Way galaxy. Now, it's at this point I want to rewind all the way back to the first chapter we looked at and reference my analogy that I use for the universe. Remember, I said if a room in your house is like a planet, if a house is like a solar system, if a neighborhood is like a section of a galaxy, and then if an entire city or town is a galaxy. At this point, we have gone into great detail about the things that are in your house or even in one of the rooms. When we talked about the Earth and the planets in detail, we talked about each one of those rooms in great detail. We talked about the solar system as a whole, and we talked about stars, as in all of the other the objects around us in our neighborhood when we talked about the stars. But now we're talking about the city as a whole. What can we know about the whole city? Now, if you think about my analogy for just a second, if you were to imagine being in your house, and I'm thinking this myself, if I'm sitting in my living room in my recliner, and I look out the window and I try to figure out what's going on with everything in the city around me, that's a pretty tough challenge to do. Because that's really effectively, that's what we have to work with, right? We have a one small view on the universe, and it's just what can we see from the Earth. And trying to figure out what is made of this galaxy is a difficult one. And it's one that took us in astronomy, took us centuries to get to this point. And it's only in the last 100 years or so have we even understood that there's more than one city out there. Imagine spending your entire life never getting out of your living room and trying to figure out whether or not there's more than one city in the world. Very difficult task to do. That's on the same order of what we're looking at here. Now, this particular first chapter we're looking at with the Milky Way is trying to get across the idea of what's going on with our city. This is a hometown America. What are we looking at with our hometown? How is our city put together? What do we know about our city? Well, one of the things that we know about our city, and one of the things that you can tell immediately by direct observation, if you go outside and you look, there is a band of stars in the sky. There is this clouded band of stars that we call the Milky Way. It's been called the Milky Way for millennia. And of course, because it looks like a cloud overhead. We now understand that when you're looking in the Milky Way, you are looking in the edge of our galaxy. You're looking through the galaxy. And when you're not looking there at the Milky Way, you're looking off to one of the other directions. You're looking away from our galaxy. Remember, galaxies are effectively in a disk, much like a CD or DVD spun into a disk. And if you are on that disk, you can look into or out of the disk, and you can look above and you can look below as well. And so when we look out in space, we see, if you're looking right into the disk, you see that clouded area. One of the things that you can tell is if you go outside and make some very simple observations, there are times of the year when you look at the Milky Way and it looks much thicker and much denser. And there are times when you look at the Milky Way and it's not nearly as significant. Now, this is a clue that our galaxy, this is one of the first observations, that when we look inside our galaxy, we can tell there must be some stuff this way. There's more stuff this way than there is this way. And it turns out the center of our galaxy is in the direction of the constellation Sagittarius, which is useful anecdotal information. But it shows us that we can make some observations about the big scale structure of the galaxy we're in and before we try to figure out what's going on with these other galaxies, which we'll get to in a little bit. But nonetheless, we talk about the idea of how do we know what we know. And one of the ways that we do that is, this is a great reconstruction of telescopes. In the middle of the 19th century, there was this huge debate, and really it raged for 75 years. Really basically until the time of Shapley, which we'll talk about, and Edwin Hubble, showing that these galaxies, these swirling, what they called spiral nebulae, are actually distant galaxies. So for the longest time, we thought these were just swirled clouds of gas. We did not understand that these were other galaxies. And so once we understood that there's other galaxies out there, that these things are tremendously far away, and that basically all of the matter in the universe appears to be connected with a galaxy, the question must be then, well, what does our own galaxy look like? Imagine looking out into space, looking out your bedroom window and being able to finally identify other cities out there. If you had a clear view, you could perhaps see the lights from other cities, which might make you wonder, well, what does my own city look like? And that's exactly what this first chapter was about. Now, it requires a tremendous amount of information, but one of the things that we did to identify the structure of our galaxy was, again, we rely on these things we call Cepheid variables again. Cepheid variables are quite useful in terms of measuring significant distances. Now remember, short distances end up getting used, things like parallax or a variety of other more direct methods. But when we have when we're talking about the distance across our galaxy, we end up needing a larger measuring stick, so to speak. So Cepheid variables end up being the ones that we use to do that. And so the story is, and I love this story, they talk about a man named Shapley, who really in the early 20th century, this idea of what is the size of our universe, how does this thing all put together. This was actually, Shapley was doing this in the early 20th century, but he was doing it, he thought correcting the work of William Herschel. William Herschel was way back to Uranus. That was mid 18th century. So this is 140-ish years later. He's going back and trying to make sense of it. And the story goes that Shapley was working on this, and he's working on it late at night, and when you go through this idea of talking about on 473, there's a part in italics that says he was working with measuring globular clusters. And then he made this idea, this bold conjecture that the globular clusters orbit the center of the Milky Way, which is located in Sagittarius. And the story is that he finished his work. He got to the end of the answer, and he realized what he had discovered. And he had realized the size of our galaxy. And he realized there was this amazing discovery, and he triangulated the position of where we are, and in doing so, he realized he'd made this enormous discovery that was going to change everyone's view of the Milky Way, and our universe for the matter. And he looked around, and it was the middle of the night, and no one was there. And he had no one to share this with. So he ran down through the building and found the only person he could find was the janitor. And he dragged the janitor into his office, and he explained his work and explained his research. And he told him, he said, "You and I are the only two people in the entire world that know the position of us in our galaxy. We're the only two people who understand this." He's like, this will change the way we understand the way the universe is put together. And to this day, the work of Shapley ends up being a critical part of understanding where we are in the solar system. It turns out, if you look on page 474, the Earth and our solar system, the Sun, is not in the center of our galaxy. We are in a big spiraled galaxy, like we see many of others. The Milky Way appears to be a barred spiral. But in doing so, it turns out we are half, maybe two-thirds of the way out away from the center. That the center is this way. And we can figure out the position of objects going around this. That's how we figure out where the center is. And so it turns out we're kind of, if we were to think of this as a city, we're out here in the suburbs. The solar system is not in downtown. We're not in the busy part of our solar system, or in the busy part of our galaxy. We're kind of out on the fringe a little bit, which is good because probably we would not do very well in the center of the nucleus, because the center of a galactic nucleus is very crowded. It's very active, and so it's likely that the center of the galaxy would probably not do well for creating the calm, stable, tranquil conditions necessary for life to be successful where we are. But nonetheless, the center of our galaxy appears to be a very busy area with lots of material going on. So make sure when you're going through either reading on that, you get an idea of how this is working. Now, the last thing that I want to talk about is very exciting on page 481. And it says, there are mysteries at the galactic fringes. This is very exciting because this is an area of intense research right now, trying to figure out what's going on with our galaxies, because we understand very well, based off of the laws given to us by Johannes Kepler and many others, these observations have shown that there is a problem. There is a big-time problem with our understanding of how our galaxy is put together, and the problem is this. Our galaxy appears to be missing some mass. Now, how can that possibly be so? Because where could we misput mass? Where could it go? And the idea is, when we measure the rotational speed of objects around the center, we know quite well how massive our galaxy is based on how fast things go around. The problem is, there appears to be a significant amount of mass that is simply not there. That is, when we would add up the mass of all the stars and all the dust and all of everything, a huge chunk of mass is missing. This appears to be one of the great areas that we will be that researchers will be working on for the next several decades, I believe, is the idea of why there is this matter that we cannot detect, and therefore, since we have no way to detect it, but yet we know it has to be there based off of what we know about gravity, that is what we call dark matter. So either there is matter out there that we cannot see, or everything that we know about gravity is wrong. Basically, those are our two options. So we have a really fun challenge in front of astronomers, and that is to answer this concept of dark matter. And later on, we'll talk about dark matter's cousin called dark energy, which is another fascinatingly cool part of what's going on in astronomical research right now. Now, make sure you're keeping up with the reading on this chapter. This chapter is a short read. It is a quick one. Take a look at the PowerPoint. That'll help get you through, and you should be ready for chapter 15. Good luck.